So, Algebra 1, this is day 2 of Lesson 2. We'll kind of quickly just kind of talk about the first 3 there because that was part of your homework last night. The first one is a fraction, 5 over 22. Right off the bat, if it's written as a fraction, you can say it is definitely what?
Rational.
It's rational. So we know it's rational. The question is, can we make the leap up that hill to say anything else? Is it an integer? What's 5 divided by 22? Nice or not nice? Not nice. So our answer is rational number. The second one, square root of 81. Wait, what is the square root of 81? That's kind of the question. Simplify it. It's 9. Is 9 rational or irrational? It's nice. And wait a minute, since it is one of our nice numbers, that means it is an integer. We'll go first, integer. But then since it's on the positive side of integers, it's also a whole number and natural. So I want to see all of those. Okay? And 56, the square root of 56, is that nice or not so nice? Not so nice, right? It's not a perfect square. So therefore it's irrational. So I didn't write those down because we got our homework and we talked about those yesterday. So now we have to go into graph and coordinate. So the graph for us is just going to be a drawing or plotting, right, of points. So for now, it's going to be a drawing, a number line, okay? And later, when we start plotting points, it's going to be on a 2D graph. So it's not one-dimensional. Coordinates is a point, right? Coordinates are a point or a place on a graph. How about that? A place on a graph. Something to visually represent where a number is. So on a number line, 3 is a coordinate. It's 3 places to the right of 0, yes? If I'm talking about a point in the xy plane, 4, 2, so 4, 2 means I'm going 4 to the right and 2 up. It's a coordinate. So talking about that number line, there it is. I think every single one of us should have knowledge of what a number line is. We should know that a number line doesn't always have to have a middle, as in 0 at middle. It could be away from 0. But 0 is in the middle of the whole entire thing, we'll say. It splits it from the negative numbers and from the positive numbers. We also call 0 the origin. The origin is at 0. It's in the middle, where it originates from. And we should know that if I go from 0 to the right, the numbers get bigger, and they're going to get more positive, yes? Bigger numbers. And as I go to the left, they go in the negative direction, and it's the negative numbers. The biggest thing that students need to realize is that over here, 5 is bigger than 4. Most of us all know that. But then we start getting over here, which one's bigger? -5 or -4? This is where students start to mess up because they say, oh, it's a 5, it's a 4. We know, oh, it has to be 5, right? So it's a -5? No, the answer is it's -4. -4 because it's more positive. So be careful on that. Don't get caught up in that mistake. So are there any questions on that? So what are we going to do? What we need to do in our homework is we need to take a group of numbers, real numbers, and plot them on a real number line and put them in order. So our job is to not only graph them, but then at the end, put them in order. But guess what? when you naturally graph them on a number line, they will end up being in order. Now, here's the problem. How many of us know what 5/3, -4/3, 2/3, and -1/3 are? Just off the bat. Do we know what those values are? Can we put those in order? I'm actually hoping that most people can say, yes, I can put them in order, even though I don't know what they are as decimals. Why? Why would this problem be okay to put in order? What do they have? Have a common denominator. And when you're comparing fractions, you need a common denominator. And if you have a common denominator, you look at the tops and say which one's bigger, which one's smaller. It's just like a normal number then. So you can almost look at that first group and say which one is the smallest number. So -4/3 is the smallest number. And then the next one is -1/3. Then it goes to 2/3, and then it goes to 5/3. We can hopefully see that, but let's put them on a number line to make it easier for us. We could leave them as fractions, or we can convert it to decimals. I think most of us know where decimals are. So, take your calculators out and convert those to decimals. 5/3. 5/3 is what? Let's go 2 decimal places. What do we have? Go ahead. 1.6 repeat. Okay. Next number. -4/3. -1.3 repeat. What's 2/3? 0.6 repeat. And -0.3 repeating. So everybody's gotten that? Now, this is where we start to make our number lines. When I start to make my number lines, I'm going to look at my biggest number, my smallest number, and I am going to make a number line that fits my data or my points. I'm not going to make tick marks that go by tens, will I? No, I'm not. The numbers aren't that big. They're not that far apart. So we know that the smallest number is just over -1, and the biggest number is almost a 2. So I'm assuming when I go to make my number line, I'm going to have 0 in the middle because it's eventually going to pass through 0. But I think it'd be okay just to put tick marks and go by 1 in each direction. Is everybody okay with that? I'm keeping them kind of spaced out because I know that my points are going to fall inside of those. It's nothing fantastic. Everybody can have a different number line and they still can be right. As long as their points are in the generally right place. Okay, we're not using graphing utilities that, if we use Desmos to graph, I don't know if we can graph. I think you can graph on a number line. Or you can graph on at least on a 2D graph. It's not going to be perfect. Graphs aren't perfect when we make them. And we'll talk more about that when we start to use them to find answers. So let's start with the first one. The first number is 1.6 repeat. 1.6 repeat. It's just over halfway, right, between 1 and 2. So somewhere about here. I'm going to label it because we're going to have a bunch of points on here. -1.3. Somewhere about there. Everybody, is it okay with that? Question? .6 is just over halfway. 0.6 repeat. And the last point, -0.3. we now have our order, don't we? We've graphed them, and we have an order. Our order is right here, negative 1.3 repeat, negative 0.3 repeat, positive 0.6 and 1.6. Now, I could write that down. We could just write that order, but that wouldn't be what I would consider the best answer. Why? Why would I not want to write negative 1.3 repeat, comma, negative 0.3 repeat, comma, positive 0.6 repeat, and so on? Why is that to me not, it's right, but it's not the best answer. What did we do in the first step? We converted. So they're not even the original points technically. So what should I do? Yeah.
You put them back to graph.
Put them back to our fractions. So which one is the negative 1.3 repeat? And notice that when I converted them, I put them right underneath. So it's a negative 4/3, comma, the next one, negative 1/3, 2/3, and 5/3. And we got to order them, and it should be least to greatest. To save time, we're not going to do the others. Number 1, convert to decimals, plot them on a number line, and then convert them back to their original form. Notice in some of the other problems, they're already there. They're already in decimal form. One thing I want to highlight, though, is right here. What is that thing? What is 6 4/5? Kathy? It's a mixed number. I don't like mixed numbers. How do you convert those to improper fractions? You say that again?
You plus the 5 and the 6, and then you multiply the 6. Oh wait, do you multiply them? You
Multiply first, right? 6 times 5, which is 30. Add 4. So it's 34 over 5. So in this class, guys, you'll most likely use improper fractions because if I want to add them and subtract them, I need to have a common denominator, right? Or if I want to multiply and divide them, I need to have numerators and denominators that I can quickly put together. So remember, it is multiplying the whole number times the denominator and add the numerator and put it over top of the same denominator. Okay? So the rest of that shouldn't be too bad. This is the one that I want to get to. This is writing a repeating decimal as a fraction. So, what you got here, as you look at the example below, it's 0.7 repeat. 0.7 repeat. I want to write that as a fraction. How do I do that? So this is how you do it. You, number 1, set the decimal equal to n, or some variable. You will take whatever that is, so it's 0.7 repeat, and set it equal to a variable. Step number 2 says you multiply both sides by a multiple of 10 for as many digits that repeat. So, in our problem, it's 0.7 repeat. 7 is the only number that repeats. So I'm going to multiply by 10. If this would have been 71717171 repeat, right? So repeating 71, that's 2 digits. I'm going to multiply by 100. If there were 3 digits in that repeat bar, I'd multiply by 1,000 to both sides. Okay? Number 3, I'm going to subtract the original equation from the multiplied one. So you take your new equation and multiply the original, subtract the original. And the resulting piece or equation that's left, you divide to solve for the variable, and you're done. So let's give it a try. As I said earlier, I'm going to say n is equal to 0.7 repeat. That's step number 1. Step number 2 says multiply both sides by what? 10. So let's do that. I'll change colors for us here. I'm going to multiply 10 over here and 10 over here. So I get 10n equals what? What happens when I multiply by 10? I get 7. I get more than 7. What does the repeat mean? It's 0.77777777. Because when I multiply by 10, the decimal place gets moved, right? Over 1. So it's more than just 7. It's 7. Yeah, 7.7 repeat. Wait a minute. So you're multiplying by 10 and the repeat's still there? Yeah, because the 7s are going on forever, right? Now, in step 3, it says subtract the original is the red one, from the one in the bottom. So what I'll do is I'm going to write it underneath. Notice I put the decimal places in the same kind of column. And then all I have to do is subtract them. What's 10n minus n? 10. I got 10 candy bars, and I give a candy bar away. How many candy bars do I have? Huh? I got 10 candy bars, and I give one away? I have 9 candy bars, right? I can't just get rid of the label. So I have 10 of something, I give one of them away, I have 9 of those things. So 10n minus n is 9n. 7.7 repeat, and you subtract away the 0.7 repeat. What's left? Just 7. These are gone. And can you solve for n? To get n by itself, it's 9 times n. You divide by 9. And so you get 7 over 9. Take your calculator, do 7 divided by 9, and you get 0.7 repeat. We did our job. This works every time. So wait a minute. Remember yesterday we talked about rational numbers, and that if it's a repeating decimal, it can be considered a rational number because you can write it as a fraction? This is why. Okay? So make sure you're multiplying by the proper multiples of 10, subtracting, and then divide it out. Next one is simplifying square roots with perfect squares. Remember, a perfect square is when you take the square root and it's rational. A square root, remember, was one of 2 equal factors of a number. Guys, I would start to remember your perfect squares up to 20. As in 20 squared. 1 squared is 1. 2 squared is 3 squared. 4 squared. Then it goes to 25, 36, 49, 64, something going on, right? I would, at this level, know all the way up to 20 squared. 20 squared is 400. If you start to do that now, the rest of your math career starts to get a little bit easier. Because you're going to start to see these numbers come up a lot. And so what they're doing is we're going to take a little step further than just simplifying the square root of 25, which is 5, and going to fractions. Essentially, guys, when I have a square root of a fraction, I can split that square root to the top and to the bottom. Yeah, that's pretty cool. And then, what's the square root of 4? 2. What's the square root of 121? 11. Your answer is 11 over, or 2 over 11. That's it. Now wait a minute. How do I know if I just did this right? What does it mean to be a square root again? One of two equal factors, right? What happens if I take 2 over 11 and multiply it to itself? What's 2 times 2? What's 11 times 11? Boom. Is that not the number? That was, wow, that's a bad arrow. Isn't that the number that was inside the square root? Boom. Mind blown, right? Now, we all know you cannot take a square root of a negative number. In part B, are we taking the square root of a negative number? No. We're taking a negative of a square root. We're not taking the square root of a negative. So therefore, yes, we can do this. Will the book try to scare you and put a negative inside? They will. And then what will you say? Nay, nay. Okay. Just means no real solution because there's no real answer. So, the negative, guys, gets to stay up front. What can I do with that fraction then? Split it. Square root of 49 over the square root of 256. The negative goes along for a ride, like you guys do when you guys want to go someplace. Mom takes you in the car. I'll drop you off on the way back through, right? What's the square root of 49? And square root of 256? 16. So the answer is a negative 7 over 16. Why does this work? Because the negative is out front. When we're taking the square root, it's really 7/16. The negative is placed along the side. Any questions? The next one is estimating, or aka rounding to the nearest whole number square roots that are not perfect square roots. So I got some steps in there. Again, this is why we do the outlines, right? You don't have to copy all this down. As we can see for our examples, I want you to estimate the square root to the closest whole number. Of course it's going to be a whole number because it can't be an integer always, because you can't take a square root to get a negative. So the square root of 15. Square root of 15 we know probably is not going to be nice, but what's the closest nice number it is? It will be 16. Let's actually give me 4. The answer is 4. But what? Number 1, find the closest perfect squares below and above that number in question. 2, decide if your unknown number or your unknown square root is closer to the top number or to the bottom number. And then 3, round the unknown square to that closer square root. Now, what do I mean by that? That means square root of 15 is in the middle. 15 is in the middle. Square root of 15 is probably below what perfect square? It's less than, what's the next number that would be nice when I take a square root? 16. And we know it's greater than what number? 14 is not a nice number. 9. 9 is a perfect square. The question then you have to ask yourself is 15 closer to 9 or is it closer to 16? So it's closer to 16. So I do that and say, hey, if I was to round it, it would end up being 4. Go ahead and take your calculator. Put square root of 15 on there. It's going to end up being 3.887 la-di-da-di-da. If I was to round that to a whole number, it would end up being 4. Do the same thing with 130. 130 is not going to turn out nice. 130 is between what two perfect squares? What's that? 144 on the top side and 121 on the bottom side. which means it's either going to be 11 or it's going to be a 12, right? When I round it. 130 closer to which one? 121. So therefore the answer is 11. No calculator needed. Guys, the whole point of this is not to take your calculator to figure this out, because then that would be no sense of teaching you this stuff. It's to use the idea which one it's closer to of perfect squares, and you have your answer. Homework for lesson 02, day 2 is page 10, 13 through 35 odds. Have a fantastic day.